So we had two solutions to resolve in our lightning credit round. You had 5 minutes to use a CIDR template, a /28 template, and a /29 template to break out the specific solutions. If you're looking at an IP address of 123.197.82.211 on a /24 network, you're tasked to use the CIDR method so that each subnet is a /28, uses a /28 subnet mask. And basically, you want to provide the correct specifics for the new network values required for the solution. So if I take this value and I'm looking at a /24, this is the host address I need to keep in mind as I take a look at the potential solution. I'm going to open a /28 subnet mask template. Basically, let's see if we can enlarge this a little bit. A little easier to see. So if you have a /24 network and we move it to we break it out with CIDR to a /28 network, the mask increases by 4. So there's 4 more ones in the subnet mask. The number of networks this will create are 16 networks. The CIDR multiple is 16, meaning there are 16 addresses total you can use. One is designated network ID, one is designated for the gateway, and one is designated for broadcast. So that leaves 13 remaining. If I remember my host address of 211, and I go back to my listing here, 211 fits in here on network 14. So my network ID is 208, the gateway is 209, and the broadcast is 223. That would be this answer right here. And then I'm doing the same thing, only now I have to go to a /29 subnet mask. What are the corresponding values? If I use my /29 solution, that's an even larger breakout. If I'm moving to a /29, that's a subnet mask increase of 5. The number of networks it creates are 32 networks. There are 8 addresses in this, the CIDR multiple is 8. The possible hosts available, host addresses usable, are 5. If I look at my client address of 211 that fits in here on network 27, once again, I have a gateway of 209, a network ID of 208. What a coincidence. But my broadcast address is 215. So in that case, what happens? It just so happens that these network boundaries for network 27 and network 14 coincide with each other in terms of the breakout just for the first 2 values. And that happens on occasion. Any questions about our CIDR opportunity?
No questions.
Okay. All right, so if I choose this one with the 215, I should be able to save and submit. And I should have.
Professor Kantop, you had an error in the first one, yeah. Oh.
I did?
Yeah, it was the broadcast was supposed to be 223. You chose 255.
Oh, I was in a hurry. Yeah. Yeah, you're right.
I also saw that the third option too looks like it's the same answer.
Ah, okay. Right. We'll fix that. If you answered either one that's correct, you'll get credit. Okay? Any questions on? Yeah, it doesn't take much. It doesn't take much for a single mistake. And yeah, if you're in a hurry and you just shoot from the hip and you don't verify, it's easy to get something wrong. So you always want to validate your answers. We are going to, I want to call out that for our last module, you have a few more objectives than we normally do. And the number of points for this module, the assessment of this module, this module assessment will run 10 points total. And there will be 2 solutions instead of 1, right? I'm modifying this list down here, but basically you'll see that there's a few more learning outcomes, and we'll also include some additional slides. In any case, it'll be really important to get as early a start on the study guide as possible. What I'd like to do now is get back to finish our topic with that we were covering on Fridays. So basically, we were talking about how DHCP, we wanted you to understand the interactions between ARP, DHCP, and DNS on the different layers. So ARP plays on layer 2. It assigns and it helps track the MAC identity to the IP network address. So ARP creates a table. DHCP assigns the IP address. Once a client advertises that they request an address, the DHCP server assigns an address. This can be automatically registered in DNS if there's a name for the device or the client or the system. Then there's a second layer of association between the name and the IP address. So MAC address to IP happens with ARP and DNS. I mean, ARP and DHCP. DHCP assigns the address, and then ARP stores the association between the MAC identity on the interface and the IP address locally. And then if DHCP is set up properly, DNS picks up that IP address and says, oh, hey, here's the name of the system or client or device. And it associates the name with its unique IP address. And that allows you to work with named resources on a network. We're going to be talking quite a bit more about DNS and named resources and zones today. So you have a DHCP scope, you have an ARP table, and you have a DNS zone. And we said that if I talk about any of those 3 terms, you have to know what it applies to. So if I say, hey, you have some network data and it's some kind of table, you'd go, oh, well, it's probably ARP, because ARP is what provides a table that associates MAC identities to IP network addresses. If I talk about a scope, we're talking about DHCP. If we're talking about a zone, we're talking about DNS. Probably be a matching question to that effect. Oftentimes, when name references are used to create access for named resources across a network, there can be simple misfires that are resolved by specifying what's called a fully qualified domain name. If you had a server named Titan and it was part of team.org, like Team Titan, kind of, basically, if you specified titan.team.org versus Titan, the reason we're talking about this is as you're creating software for network applications, it's important for you to specify with your potential customers and users that you want them to use fully qualified domain names in order to reference those resources. We also talked about how DHCP registers an IP address for a device or system for a specific period of time. It's called a lease period. It leases that for a certain duration. Normally what happens is that if you're in a busy environment, you should have a shorter DHCP lease period so that the addresses are recycled much sooner. But if you're in a stable, unchanging network, you can work DHCP leases of 3 to 5 days. A lot of times the default is set much higher than that. That's not a good practice. In any case, the thing to remember is as we were closing on Friday, I said, did you catch this? A client is powered off, but it still has a leased IP address. That means somebody else can't use that address. You cannot duplicate the same IP address for different devices, active devices on the same network. So as a precaution, if somebody's leased and they check out, well, or they may just leave the environment. You know, they break the Wi-Fi connection because they have to run an errand and they're no longer on Wi-Fi. So if they're no longer connected, they're still taking up an IP address. You have to automatically recycle these, right? No other client can use the address, even if it's set to automatically reset, unless that DHCP criteria is set properly, okay? Sometimes you have network applications you design, and it's simple network issues like this that create issues, and your network application cannot update properly. Cannot update IP addresses with names, cannot update MAC addresses with IP addresses on layer 2, and these create simple repercussions. Since many network resources are recycled due to limited availability, these interactions keep things running smoothly. And when they don't run smoothly, things are not smooth at all. So basically, if you are in a network environment where things are disruptive and connections are dropping, it could be that there's an identical IP address that's active in the neighborhood. The IP addresses were not recycled properly. Any questions about what we were finishing up on Friday? This interest is covered in your addendum. So this is in the addendum to the study guide. Today, what are we going to cover today? We're going to cover how network segmentation, proper network segmentation, leads to a conflict. Basically, the tech professionals, there's a bad practice that they often develop as a result of the network segment. If proper network segmentation is performed, it is a very common thing for local techs to set up some extra routes just for ease of support, and it kind of undoes everything. We'll explain that in greater detail in just a moment. The second topic for today are DNS Essentials. So I want you to understand the two main components of DNS and how it works and what it does. And I may end up referring you to a short YouTube video. I think there are some very efficient YouTube videos that explain DNS rather effectively. Any questions before we continue?
I do have a question pertaining to the lightning credit.
Yes.
I mean, I was late but I did it anyway, and I realized that there was a duplicate question.
No, it's
Like,
not a
there were two
duplicate
questions that said the same thing.
It's not a duplicate
It's
question.
not?
Yeah, it's a different set of tasks. The second question requires you to break
No,
it
but,
/29
fine.
instead of a /28.
no, I know it's not the questions themselves. Sorry, I meant the duplicate answer
Oh,
for the
duplicate
first
answer.
one.
Yeah, that's already been brought up. We already
I
did
see.
that. Yeah. Yep. If you had tuned in a few minutes earlier, we already went over that. So that was unintentional. I'll go ahead and post credit for people who did the lightning credit during the time allotted. The whole idea of posting lightning credit was to get people a chance to work up something quick at the start of class. And if you show up after that time period, the deal's off. So the catch with lightning credit is you get to do it from the start of class until like 5 minutes after. And sometimes if we're running a minute or two behind, we say, okay, until 7 after. That's what we did today. Okay. If you completed the lightning credit after that, you won't be logging any additional credit. We'll be offering lightning credit for other things on Friday and Monday of next week. And that Monday of next week will be our last class. So if you can tune in sooner, and that would be good, okay? Does that cover your concern appropriately?
Yeah.
Okay. So let's look at the conflict. What is it that's actually happening when you do what you're supposed to do for CIDR, and you have smaller, more efficient networks? That's a good thing in a mid-sized to large organization. So if you are working for someone like a mid-sized company or a government agency, so if you're working for WAPA, if you're working for Kmart, if you're working for VIA, if you're working for any kind of organization to scale, if networks are segmented properly, suddenly what happens is that the IT shop has a lot of smaller networks. They have a lot of smaller networks. And here's the thing that we're hoping everybody understands. So let's take a look at our /28 network again. So let's take the example that we just did for the lightning credit. Before we do CIDR, a 211 client sitting right here on network 14. How many other clients can that system see on the network before CIDR is performed, when it's just a /24? Well, let's think about it. Before CIDR is performed on this particular item, a 123.197.82.211, right? If we look at this, we're dealing with a 123.197.82.0 address. This is a Class C address. So before CIDR is performed, we're dealing with class-based networking. In that case, the network ID is 0, the gateway is 1, but what's the broadcast? I collapse all of these other subnets. The broadcast is 255. And the usable addresses run from 2 to 254. So anybody that's on an address that's from 2 to 254, they can all see each other. They can all get into each other's Kool-Aid. If I have assets I want to protect and I want to segment my network, I want to separate finance from, does everybody remember in the last module we talked about VLANs? Separating administrative and finance and operations and students and professors and all that. Everybody remember this?
Yes.
Okay. If I want to set up all of that, that's a great thing to do. So I can use CIDR and I can break it out, let's say 4 or 5 ways, right? So I have smaller networks, and after I perform CIDR, that same client 211 that ends in a .211, it can only see clients with addresses that start with 210 and end with 222. There's only 13 possible network hosts in that network. And what happens is that the folks in the IT shop, the information technology, the infrastructure guys, the information systems and IT folks, they say, well, whenever we have a problem with network stuff, oh gosh, we got to get out of our desk, off our screens, walk across to the network where somebody's having an issue, and we have to troubleshoot in that network environment. As a matter of convenience, what they do is they set up routes between networks. What I'd like to do is give you a preview of coming attractions now for one of your solutions. So one of the solutions we're going to perform in this final module has to do with creating routes. And if you look in our YouTube channel and we scroll down here, I'll be posting a solution that shows you static routes in Packet Tracer.
Good afternoon. This is Professor Ken Top, and it's because the routers are stubborn unless you force them up.
Can everybody see this?
Yes.
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 Okay. So this is a preview of coming attractions, but basically, excuse me just a second.
I sent it through the wall, brother.
Yeah, we've got a live mic, Shamir, and we're hearing all your clicks and your blah, blah, blah.
I know.
Okay. All right. Just wanted you to be aware. All right. Let's see if we can get back to this. All right. Everybody can see this again? Yes?
Yes.
Okay. So we're talking about CIDR and how cool it is and how good it is and how it makes for a much better managed network, and you have less real estate for hackers to play with, and you have much more control over those subnets. But the reality is, for the network guys, they don't really, even though it's a best practice, they don't really like it. Here's one example why, and I want you to pretend that for a second here, instead of using a 192.168.9.0 network on this side, and a instead of a 172.169, I want you to pretend that we have a 192.168.10.0. Let's say that we were doing some CIDR and we broke down the networks so that you had adjacent networks. They're still different networks. The important point is that PC0, one of the things that's really irritating about the computer industry, you know that the first device or first assignment is actually a 0, right? Not a 1. So router 0, gigabit interface, the first gigabit interface is gigabit 0. The first switch is switch 0, right? This is just a normal convention. The first PC that connects to those networks is PC 0. Everybody with me so far? You have a network here, and you have a PC over here, and then let's pretend that this network is actually a 192.168.10.0 over on this side, okay? And let's say that they're adjacent but separate networks. We've created segmented adjacent networks for better security and management, right? Basically what happens is that only connected devices and systems in the one network can see other devices and systems in that network. So the .9 systems and devices cannot see the systems and devices over here. They can't, unless there's a route in between the two networks. So when you have someone you want to talk to outside of this local network, if this PC says, hey, I want to talk to 192.168.10 I want to talk to the PC1 over here. You have to have a route that connects this network to this network. And what often happens is that the IT staff sets up all these separate subnets because they know that they're supposed to do CIDR and they know they're supposed to have separate LANs. But then they set up routes in between all of the subnets and string them all together like a giant Christmas tree so that all of these devices can talk to all of these devices, can talk to all of the next devices, can talk to the next, and so on, all the way down the line. Because that way, from their desk, they can manage all of the PCs together. Put another way, they create routes between the adjacent subnets and the segmented networks they intentionally create for better security so that they can manage them with greater ease. And in so doing, they completely undo all of the work they did to set up the subnet. They completely mitigate, cancel out, ruin, destroy. I'm just saying it's horrific. Basically, for the sake of ease of management, they set up these routes so that they can sit from their desk over here on a management network and they can touch everybody down the line. Well, the moment you do that, everybody can talk to everybody else. So the whole purpose of having segmented networks is ruined. Pretend we have a server network here. Everybody with me? So we have PC, and we're going to say we have a bunch of servers over here on the left, okay? And let's say it's the 168.0.0 network. So we have a whole string of these subnets and they're all together, but on the 192.168.0 way to the left on the very end, we have a set of servers. What should happen is that the next clients in the next subnet should have a route to see the servers, but not to see all the other clients. Then in the second LAN, they should have a route to see the servers because they need resources from the servers, but not the first set of PCs and not the third set of PCs on either side, right? Does everybody follow what I'm saying?
I do.
This set of PCs and devices and systems would have a route to see the server systems in the VLAN 0, right? 0.0, way over on the end, but they wouldn't have a route to see the very next subnet on either side of themselves. We don't want finance to get in the middle of admin, to get in the middle of operations, to get in the middle of teaching, to get in the middle of student dormitories, to get in the middle of the sports department, to get in the middle of the the cafeteria stuff. I mean, think about it. You have all these different functions. What we want to do is create the segmented networks, and then we want to have routes so that specific networks can talk to specific networks. Now, in the exercise that you're going to do for your solution, you're going to create a similar setup here. You're going to create a router and a router and a switch and a switch. And then you're going to have some PCs and laptops in network 1 and some PCs and laptops in network 2. And you'll follow along this video, which is basically a 20-minute video. And I use Packet Tracer to build out this entire set of networks and then connect the two of them. The same thing happens on the internet. So when you have a local area network and you need to talk to the internet, you have to basically find a path or a route out to that internet. And what's important to understand is that, well, IP routes are part of that. We're going to go into more detail about routes on Wednesday. Wednesday is going to be a special class because it's the first time we're teaching that topic separately with some additional resources. So I hope you can clear your schedule and you want to bring your questions. But I'd like you to watch this video as a preview of coming attractions. I want you to, I'll post this link online. In fact, I'll do it right now and then I'll email you. But you're going to get a taste of what it's like to set up a route between two networks so they can talk. The thing that I want you to understand is that there's a lot of legwork into doing just the first pieces of this. And as you practice more and you do it on a semi-daily basis, you get faster and better at it. And what often happens is that technical and computer science people really don't mess with this very often. The whole idea of being able to set up a route so that you can talk to networks you're not supposed to talk to is a loaded gun. If you use that loaded gun indiscriminately, people get hurt. If you use that loaded gun intentionally to create connections between the server network and the other sets of users, so they can't see each other, they can't get into each other's business, but they can get the resources from the organization, the central resources they need to function, then you're doing what you are supposed to be doing in a best practice fashion. I have found few textbooks really talk about this. Our own author, Comer, has been writing network. He's a subject matter expert who is truly world-class, and he's very well respected. But you can tell from his textbook that he hasn't spent a lot of time in the real world, because he's never really seen this kind of stuff where, well, okay, I set up all these networks. Why? Because I had to. Why? Because it's a best practice so we can have better security and management. Okay, but then what did you do? Well, I'm lazy. I want to sit at my desk, and over here in the IT shop, I want to be able to support and manage everybody and everything. So I just stitch all these things together again so they're one big network. Well, hello. If you want one big network, why do you subnet mask in the first place? That just hacks me off. When I'm a certified systems engineer and I'm hired as a consultant and I go in there to see why something is eaten alive with exploits and exposures with all sorts of networking problems, when I get around this territory and I see cases where the service providers aren't using the best practices properly, it's like, why didn't you? This is why people have just one big network, right? And it's horrific. They don't want to do the extra weeds. I guess I'm kind of preaching here, but I'm very passionate about this idea that if you do this kind of thing correctly, you get the best of both worlds, right? And you need to be aware in the workplace of how the Hatfields and the McCoys, two opposing interests, right? The IT people and the security people, they're always kind of warring with each other. You want to structure the network, you want to define and control exactly which resources have which resources. Now, get firewalls in the middle of this and it gets even worse. Here's a bad example. The IT help desk itself wants to have free access to clients at each of the different subnets and VLANs in an organization. In this case, they add routes to all other subnets in addition to the route to the servers and the internet. These are the routes that matter to the servers and the internet. Every subnet, every segmented network needs common resources. Don't you want to be able to efficiently handle backups and overhauls and stuff? Sure. So you have a server network and you have the internet, the larger global network, right? We need those routes. What we don't need are for people to just overuse a tool, okay? Did you know that you can use a nail as a fastener so much that if you put too many nails in a board, the board becomes weak? Has anyone ever seen that, where somebody puts too many nails in a board? Now the board is splintered and it's fractured and it's messed up. I see this. Yeah, I see this example all the time. The good example is the ITS. The IT help desk wants each subnet to be incapable of seeing other subnets except for the internal servers in the network. There are better ways to centrally manage systems via dedicated support and backup networks configured solely for internal use with a much smaller subnet to allow larger clients. There is no path to the internet and server VLAN, and a firewall prevents ports except for those that are needed for supports and backups. What am I talking about here? It is a little known thing in networking, and I really wanted to share this with you because oh my gosh, when people, whoops, when people do this intentionally, it's just a thing of beauty. Here's my network configuration, right? Pretty much everybody knows this, right? Everybody sees this.
Yep.
And everybody's seen this. Hang on just a second. Most everybody's familiar with this screen. And most everybody is familiar with configuring an IP address on a given network interface. But what they don't realize is that you can configure additional network. You can configure another TCP/IP address on top of the same IP network. So in your IP settings, right, looks a little different in the newer version of Windows, but basically if you go into advanced, you can put another address on the same network interface hardware. So what am I saying? I'm saying that the IT help desk could have a support network that's isolated, that isn't connected to the internet, that isn't connected to the server VLANs. It's not connected to, but basically it's a very large network that has a very small subnet mask so that you can basically put everybody on that thing, right? And what you do is you allow the ports except for those that are, you block all the ports except for those that are needed for support and backups. We're going to talk about ports in just a moment. The important thing to understand is that most people don't realize this is a possibility. You can have a separate network running on the same hardware interface card for support reasons, and that network doesn't touch anything that you're working with, but the IT guys can have what they want, and they're not exposing everyone else to everyone else so they can have their cake and eat it too. They're just not aware that this is a possibility. Most people don't realize you can put more than one IP address on a physical interface card, meaning you can use it to connect to more than one network. If the network that you're connecting to is good for service and support and it's internal only and it doesn't go anywhere else, then it's going to help with management and that kind of thing. The other part that we wanted to make sure that we had a little bit of cover for today was this idea of how there are some common tools you can use to troubleshoot network connections. So when you have a network connection that isn't working very well, if you try to ping from this PC to that PC, even if you know its address, if the ping fails, you don't know what the problem is all along the way. But you can use some other tools, one called PathPing and Tracert. And then you also use DNS for troubleshooting. You can create a host's record with a name to address association locally. That'll help. You can create local routes if you have to. You can build some DNS records to help with an issue, but you can also query the DNS server to see if there are name to address associations. Sometimes those are outdated or they're not known. But two of the most important ones are Tracert and PathPing. If I basically open a command prompt and run it as an administrator, and then I want to connect myself from my own location out to system out on UVI. So I'm going to ping 146.22, this is an active address that I know is really working. 226.249.51. Now that's working. But if it failed, all I'd get is I'd get no response, right? I'd get a failure for the thing, and I wouldn't know exactly what it is that's causing a problem. So if I use PathPing to the same, so I'm just going to do this and add the word path in front. What's going to happen now is that it's very similar to Tracert. So what it's going to do is it's going to send pings to each of the components along the path, and it's going to report back each of the components. And where you have the misfire, you can tell, okay, I'm not getting any further than this router, which means I don't have a route, or I've got some kind of other administrative issue I need to resolve there for my connection to work. So if you structure your networks properly, these tools work very quickly and very efficiently to give you the information you need. You see here, when I'm pinging from my laptop out to the system at UVI, it's taking a little longer to get the rest of these statistics, but it's taking a hop at each point along the way. Here's a very bad indication. Normally, after a point, when you're off of your local area network, everything else should be public. If you have something that's private in the mix, it means that a private internal address is exposed along the way between systems. Put another way, when somebody set up their networking, they included in their routes a private internal address as part of the connectivity between public network resources. And that's very, very bad, because what it means is that that private internal network is accessible. So you have people doing all sorts of weird things with the routes to make life easier, and whether they're short-circuiting the barriers between the adjacent subnets, or they're just trying to make something work on a bigger network, if they put in too many routes or the wrong routes, you basically can undo everything. So in just a minute here, we'll try Tracert just to see what we're talking about. Does anyone have any questions about some of the stuff we've shown you at this point?
No questions.
All right, I'm going to go ahead and start another command prompt, and I'll do a trace RT or trace route. I'll do the same 146.226.249.51. So I'm sitting on my laptop and I want to see if there are issues between here and there. And the display for each of these is going to render a little differently. At some point on this side, I'm going to get, this will finish displaying in just a minute. It just takes longer. I've found that a lot of times you get information using PathPing that you don't get using Tracert. So here you see the different levels. Whichever one you use is irrelevant. The point is you can see where we're getting through the different points of connection and what addresses those different router connections have when we're trying to connect between resources. Okay, so I'm going to go ahead and email you the link for this, for your first solution. We'll review on Wednesday. I'll walk through this live it would be great if you had a chance to watch this. And if you had a chance to follow along in class. We want the Wednesday class to be a live workshop where I do it and you do it. And we try to troubleshoot issues as they come up. But it would be good if you had a chance to try to watch this and practice a bit. We have a few other topics we want to cover. One of the other things you're going to do, you will design your own domain name. And you'll see an assignment out on the module for this. But basically, starting with the assignment numbers down here, you will come up with a creative domain name for an internet resource that's your task to design. It could be the next Facebook, but it needs to be a catchy name. It needs to be an efficient name. You don't want a domain name that's too long. Otherwise, when people come up here, if they have to type out, you know, Tom's favorite website app.com, it just gets to be a little unwieldy. So you want to start giving some thoughts to domain names. We're going to create DNS zones for those domain names, and we're going to get you on your system. And after we create the DNS zone for that, you'll be able to turn your web browser open and navigate to that website based on the domain name. So that's going to happen by the end of this week also. So we'll have a number of things for you to watch in terms of YouTube walkthroughs, and we'll do something live on Wednesday and Friday. Are there any other questions before we clear today?
None that I can think of right now.
Okay.
I have one, but it's off topic. Replay.
All right. Very good.